All right, so for today, we're going to start out by looking at inverse functions. And we start by saying that a function f has an inverse f inverse if and only if f is bijective. So that is important. A function only has an inverse if and only if it is bijective. Since that function can be represented as a mapping, a set of ordered pairs, a graph, and a formula, you must be able to find the inverse of a function given in any form. So, inverse of a function is not something that is new to us. We have looked at it since CSEC. And what this is saying is that a function can be represented as a mapping, which could be, you could say, an arrow diagram, as a set of ordered pairs, a graph, and a formula. You must be able to find the inverse of a function given in any form. Now here it is. Suppose that f is a one-to-one function, meaning that it is injective. The correspondence from the range of f back to the domain of f is called the inverse of f. So the correspondence from the range of f back to the domain of f is called the inverse of f. Technically, what he's saying there is that to find the inverse of a function, you need to interchange the domain and the range coordinate. So if you have a function represented as a mapping diagram, and it is a one-to-one function, it's an injective function, it's a surjective function, it's a bijective function. So if you have a bijective function and you interchange the range and the domain values, meaning that the domain becomes the range and the range becomes the domain, the resulting arrow diagram or mapping will be the inverse of the function. So the relationship between a function and its inverse is as follows. The domain of f is the range of f inverse. So if you have two functions, you have f and f inverse. This is very important. That first point, the domain of f is the range of f. As you all know by now, every function has what? Domain, and it has what? Ranges. When you find the inverse of a function, the domain and the range are going to interchange. In other words, the domain becomes the range and the range becomes the domain. The range of f is the domain of f inverse. So both statements are telling you that when you find the inverse of a function, the domain and the range interchange. Both statements are telling you that when you find the inverse of a function, the domain and the range interchange. Number 3, the graph of f inverse can be derived from the graph of f of x by reflecting f in the line y is equal to x. Ladies and gentlemen, whenever you reflect a point in the line y is equal to x, the x and the y coordinates interchange. So if it is that you have a point xy and you reflect it in the line y is equal to x, the point xy is going to become yx. For example, if you reflect the point 3, 4 in the line y is equal to x, it's going to become the point 4, 3. Whenever you reflect a point in the line y is equal to x, the x and the y coordinates interchange. And that is why whenever you reflect the graph of a function in the line y is equal to x, the image that you get after the reflection is the inverse of the function, is the graph of the inverse of the function. All right, let's have a look at some examples. Example 16. Example 16 says, find the inverse of the function shown in the diagram. So obviously this is a bijective function. We want the inverse. So let us say that this function is f. Let us say that this function is f, and they want the inverse. Now, let me just say it for everybody to get it once and for all. When you're asked to find the inverse of a function, technically, you're being asked to interchange the domain and the range values. So the range of f is going to become the domain of f inverse. Now the range of f is what? 1, 2, 3, 4. That is the range. And the range is going to become the domain of f inverse. So this is 1, 2, 3, 4. And this is f inverse. And the domain of f is going to become the range of f inverse. A, B, A, B, C, D. Let's what? So 1 is going to be mapped to A, 3 is going to be mapped to B, 2 is going to be mapped to C, and 4 is going to be mapped to D. So if you're asked to find the inverse of a function, technically what you're being asked to do is to interchange the domain and the range values, to interchange the x and the y values, so that the domain and the x value, so that the range of f becomes the domain of f inverse, and the domain of f becomes the range of f inverse. All right, so now we're at example 17. Example 17 says to find the inverse of the function. All right, so this function here is represented. Let us say that this is the function f of x. Now, f inverse of x, remember, whenever you find the inverse of a function, first of all, the function has to be a bijective function. So if you interchange the domain and the range elements of a bijective function, the resulting function is the inverse of the original function. So let's just interchange. We're gonna have what? 5, 1. So 1, 5 becomes 5, 1, comma, 10, 2. I'm simply just interchanging the x and the y coordinates. This is what? 15, 3. Next we have 24. Next we have 25, 5. So if f represented as a set of ordered pairs is a bijective function and you interchange the x and y coordinates in the ordered pairs, so it's a bijective function represented as a set of ordered pairs, and you interchange the x and y coordinates. That is, you interchange the domain and the range elements. The resulting function is the inverse of the original function. Example 18. In example 18, f of x is equal to 4x plus 2. And we're asked to find f inverse of x. Now, at this stage, you should be able to just look at a linear function and say what the inverse is. For example, I can just look at the function f of x is equal to 4x plus 2 and say that the inverse is x minus 2 divided by 4. However, if you can't do that, you can do what you learn at CSEC. F of x is equal to 4x plus 2. You're going to say what? Y is equal to 4x plus 2. Then you're going to interchange the x and the y coordinates. Then you're going to make y the subject of the formula. So we need to get y by itself. So x minus 2 is equal to 4y. Then I divide both sides by 4. And when I do that, I'm going to have y is equal to x minus 2 over 4. And the fourth and final step is to say f inverse of x is equal to x minus 2 over 4. But as I said earlier, at this stage, you should be able to look at a linear function and say, without going through all this calculation, what the inverse is. If you can't do it, then just go through the calculations. Example 19, we're told that f of x, well, this one is not so easy. You have to go through the calculation, is equal to 2x plus 1 over x minus 3. We want the inverse. Finding the inverse is a 4-step process. Step 1, take out f of x and say y is equal to 2x plus 1 over x minus 3. That's step 1. Step 2, x. Interchange x and y. This is the most important step. Wherever you see x, put y. Wherever you see y, put x. Now, step 3 is to make y the subject again. So we need to get rid of the fractions. And if I have one fraction is equal to one fraction, to get rid of the fraction, I would cross multiply. So I have 1 times 2y plus 1 is 2y plus 1 is equal to x multiplied by y minus 3. Distributive law. I'm going to have 2y plus 1 is equal to xy minus 3x. Next, I need to get everything that has y in it on one side and everything that doesn't have in y on the other side. I'm going to take my minus 3x on the right over to the left-hand side. So that becomes positive 3x plus 1 is equal to xy minus 2y. I'm at the third step, and at the third step, you need to make y the subject. Over to the right, I'm going to factor out a y. Y into xy is x. Y into 2y is 2. and this is equal to 3x plus 1 on the left side. Then I'm going to divide both sides by x minus 2. And when I do that, I'm going to get y is equal to 3x plus 1 over x minus 2. Now, the third step when you're finding the inverse of a function is to make y the subject again. And the fourth and final step is to take out y and say f inverse of x is equal to 3x plus 1 over x minus 2.